Morning.
Good morning.
It's Monday.
It is Monday.
We're missing one.
He'll be here shortly. He had a long weekend. He learned some new things over the weekend.
We took him to the farm. Yeah, that's for sure. Yeah,
so
that was.
He's a little slow going this morning. But
Hey, but I think he's looking at a double wide. I mean, might move to Arkansas, get out of Brooklyn.
Nice.
Get a double wide on a little piece of land.
Well,
you never know.
Well, did you have a good weekend?
I did.
I did too.
I got a little rest. It's gonna be this is a jam-packed week. So last week I thought was jammed, right?
Yeah.
Then I looked at this week's schedule yesterday, which I probably shouldn't have done. I should have just let myself be surprised when I got in this morning. But jammed up day. And today, jammed up week, but today is fantastic.
I know. I'm excited.
Yeah. We just got to get through our stuff to get to the everybody else's stuff. So now that Larry's joined us on the show from being late, Jason.
What being late? No one woke me up this morning.
Yeah. All right, let's go. We've got some bombs to drop today.
We do, and we're going to start with welding. We haven't talked about welding. We kind of did a lot of repair research last week, and we finished with some refinishing stuff. And now we're going to come back and do some more repair stuff today. We're going to start this morning off with kind of part replacement, and this afternoon we're talking about panel some repairs with BTEG Innovation. And we got a bunch of PDR group guys here. I'm excited about that as well. But we're going to start the day off with, and not just kind of we're talking about a pre-weld routine for technicians. Now, there's a few things that before we even touch the car, we need to make sure that we're doing. So we talked about some of the things that the estimator needs to know last week, and now they need to know some of the requirements, but now we're going to kind of dive a little bit deeper into what does the technician need to know before they start welding on the vehicle. And so we're going to talk a little bit about equipment maintenance. Not a lot about equipment maintenance, but we're going to really dive deep then into some of the OEM welding requirements for what they require, because it's not one size fits all, much like everything else we've been talking about. We need to make sure we're following those OEM recommendations for different parameters. So we want to kind of dive into that and talk about where to find that information. Talk about we got some Honda information, some Fiat Chrysler information, kind of show you what it looks like in there. And then we're going to close the show out. We're going to talk about practice welds as well. What we need to be doing before we actually make the welds in the vehicle. And then we're going to close out the show with a pretty big announcement that I'm super excited about.
So I want to make sure that you pay very, very close attention during the show today, because we go to a lot of shops and we perform a lot of post-repair inspections where shops fail completely by just what we're going to cover today. So you can have the best pre-estimate routine, you can have SOPs, you can send your technicians to training, you can have all the certificates hanging on the wall that you want, but if you can't do what we talk about in the next hour, odds are your repairs are failing.
And welding's pretty important. So we want to make sure that part's not failing. If we get some blemishes in our paint, we're going to probably be okay.
Unless we're Danian, and then it's going to break your heart.
Understood, understood. All right, so let's talk a little bit about equipment maintenance when it comes to spot welding as well as conventional GMA, MIG or MAG welding, depending if we're doing steel or aluminum. Machine maintenance is something that I think often gets overlooked. Making sure that we've got, and Larry, we're talking a little bit about some gun liners, with aluminum and steel, making sure that we got proper gun liners. But
having extra equipment laying around is very, replacement of parts are very important, because if it shuts down and it breaks, you can't just run down to the local store most of the time.
So it's good to have one on hand.
Yes.
What happens if I get some like bird's nesting in my aluminum equipment, for example?
Generally, with most of the equipment out there, if it does bird nest back there, it usually scars the liner, and you're probably gonna have to change the gun liner. So that's one of the biggest things that people don't realize with aluminum, and it keeps bird nesting then. And you keep scarring the liner more and more as the wire smashes into the hole as it tries to go through there, and then it all birds nets up. You got to change that gun liner. So you need to at least have 2 gun liners. My suggestion for aluminum, you order another one. And unfortunately, that big long gun liner is useless once you put it, once you take it out. Contact tips for aluminum, you probably need a whole big bag full of them.
Why is that? So here we got a bag for 1.2 meter. Why do I need a whole bag of them?
Because sometimes it burns back. It's technician error most of the time, or the setting. Well, once again, it's technician error. The setting's wrong or something like that, and it burns back into the tip and it melts on there. Not like where you get it with steel, where it clicks on and you can kind of move the gun around and it pops open. It's got the little ball in the end. This ball melts right onto that copper and you can't get it off.
Over.
Now you got to go ahead and pull everything out. The whole wire out. With steel, you can have a few of them. It's always good to have a few of them laying around, but you're hardly going to change those. Aluminum, you're going to change a lot.
Well, here's what happens, right? So shop owners, there's a reason why most shop owners don't buy the painter as guns. right? It's because we want the painter to take care of them. The painter's going to pick and choose what he wants for certain applications. When I've gone to some refinish or some body shops where they've been supplying the paint guns, well, sometimes we have maintenance issues. We have stuff getting skipped back. Okay, your body men don't buy the welders, right? It's not their equipment. If I went to your body guy today and took his 10mm socket and ran away with it on the other side of the shop, he'd let me know by the end of the day. But the welder is considered to be yours. And so maintenance isn't a priority for technicians in some respects. So it has to be a priority, one, for you, and then two, that you drive through the shop with an SOP. Because when those go bad, I should technically stop welding, correct?
Yes.
Do they?
No.
No.
Not
We force it to go more.
If I can pull the trigger and make something that resembles a weld, I just keep on going, right?
They usually change the contact tip once the wires melted to the contact tip and they can't do anything else with it, is usually when I
And
when I
welder
see.
maintenance is not the job of your distributor. So the person you bought the welder from, it's not their job to maintain the welder. So if you're thinking that that's your plan and someone comes through, even if you are lucky enough to have a jobber come through or a distributor come through once a month, that's not enough maintenance on these welders.
Yep. And then shielding gas nozzles, Larry, we another area where we sometimes get in these little, we start getting
They
some,
just have
some
to be
stuff built
cleaned
up
off.
in there.
You don't bang them against anything. You have the pliers that you take off, you clean them. It should be kept clean all the time. Emery cloth works good to clean it up real quick.
What about
the pliers go
anti-spatter
inside.
material? What about the
No, you don't want
anti-spatter
to
spray?
never use anti-spatter material. It's only going to infect or contaminate the weld. Listen, I've seen guys take aluminum wire, and they talk about cleaning aluminum. Wipe it down. Wire brush it with a stainless steel wire brush. Make sure a magnet doesn't stick to that stainless steel wire brush, otherwise it's coated steel only. So you want a full stainless steel one, and you clean it and stuff. You're not supposed to touch it with your bare hands because of the grease. But then yet you got guys putting the wire in with their bare hands. It's like you got to wear a pair of gloves because all you're doing is contaminating every weld after that because you put your fingers all on there to try and run it through. Wear a pair of gloves or something.
Yep. So we've got this 55, 54 electrical wire. It's in a bag.
Okay.
Why am I keeping this in a
So
bag?
contaminants stay off of it,
Okay.
and you shouldn't leave it in your machine. You should take it out each time after you're done.
Every time?
Every time. After you're done using it, put it back in the plastic bag, Ziploc it, make sure you squeeze the air out of it, keep it in a cool, dry place. You don't want to have any moisture building up. You don't want to have it get contaminated or anything like that.
Yep.
Leaving it in the machine out open to the elements and moisture and everything is only going to ruin it. And yeah, the wire's ruined, the job's going to be bad, but it's also going to wreck your machinery, as you go along with it. So aluminum, you need to be a lot more careful with. It's not just plug and play like a lot of people try and play on Facebook.
Yeah.
And it's not that easy to weld aluminum correctly. There's two different ways of welding aluminum. You can make it look good, and then to actually pass most of the tests, it's not as easy as everyone thinks it is. And another big tip that I'm going to tell everyone that I notice a lot, the drive rolls that they give you for aluminum usually comes with 2 or 3 different sizes. The size you read on this side is the inner one, the one you actually want to run on. A lot of guys will go, oh, I got 1.2 millimeter, flip it around and shove it on, and they don't have the right drive roll, and the wire automatically just bird's nest. So remember, when you look at the number on here, it's the inside one that you're actually running on. You flip it over, it's this outside one that's facing me right now. So that's a tip. And unfortunately, not everyone reads the instructions, and it's not that clear sometimes in the instructions.
All right, so now let's talk about spot welding just a little bit. Now, this isn't really a maintenance thing, but what happens a lot of times is, from what I've seen, is I'll buy a piece of equipment, I'll put it in my shop, and it doesn't work. And it's always the machine. It's either the welder or the welder when it comes to MIG welding.
Piece of machinery.
But now
It's the welder behind the trigger.
So a lot of times these shops will buy this equipment but they don't have the proper power at the facility. What have you seen when it comes to that?
The biggest issue is, obviously, you're in rural areas. It can be very expensive to get 3-phase 220. And these newer resistance welders need 3-phase 220. The other issue is that the electrician will come in and to try and save you a little bit of money. Well, code calls for 6-gauge wire. These need 4-gauge. They need 60, some cases 80 amp breakers. Listen to the company that sells you the equipment, and they're probably going to tell you the right thing, because probably some of you out there right now have rattling in the rafters, or rattling on the wall as you go to resistance weld. You hear the brrr, and it's the wire actually jolting around because this machine's trying to drag so much power through your wire, through the wire going to the to the telephone pole out there or the utility pole outside, and then all the way back to the to the facility that's actually creating that power. And or guys used to go ahead and resistance weld, the circuit would blow out.
Yeah.
And another big issue, I see guys sometimes they don't want to spend the money of running electrical in a bunch of different areas because it can get expensive with 4-gauge wire from an electrician. Basically, they walk in and you got to open your bank book. Well, they were going to run one section here. I'll get an extension cord; it'll save me money. Which in a case it does because it's not attached physically. The problem is you still have to get 4-gauge wire for that because every 12 inches is a drop off in electrical power. So if I get an 8-gauge wire, that's easy for me to carry a 100-foot cord versus a 100-foot 4-gauge wire, probably you and I are going to have to carry it. That's how heavy it is all wound up. So you'll have a drop off in power. The older machines would work and not make a proper weld. These machines probably won't work. If the power drops too low, these machines will kick on and go bad weld, no weld, or just give you a red dot, flashing dot that says, yeah, I can't work like this. I'm not getting enough, I guess you can relate it to oxygen. If you're running down the street with like one of these little paper masks that we all have to wear now, not so bad. You put a bandana on, it might be a little bit harder. You put a sweatshirt around your face, you're gonna run 10 feet and run out of breath. That's what's happening to this.
I mean, I know
it's suffocating from the electricity. It doesn't have enough.
I just want to see you run. 1. 2, with a sweatshirt. That would. Stay tuned for the lunch show.
and this comes from the marathon runner over here making fun of me.
Hey, dude, I'm just saying. I just want to contribute to the show in some small way.
What about the coolant? Is there any maintenance required for the coolant that I've got?
The biggest thing I could tell people is, guys, look, I understand your automobile, your car, your boat, even some motorcycles that are cooled, usually don't require you to take out the fluid and flush it and clean it, which you should. Okay, but these newest stuff is great. This stuff seems to sit a lot. It's not like a car that's being used or a motorcycle being used every day. Guys who have, I know a lot of guys out there have, and girls have those old, restoration cars and stuff. The old, 60s, 70s cars, their baby. They'll do oil changes once a year or twice a year because they don't drive it that much. But they will do the winterization because they know it just sits.
Yeah.
That's what happens with this machine. It sits. So what happens is, it starts to build up crap. And if you don't follow what the manufacturer tells you as far as changing the coolant in there, what'll happen is it gets stagnant, it starts to build up crap, it grabs stuff from the atmosphere inside the body shop, dust, dirt, metal particles, anything floating around, it'll get stuck in there. And what happens is it clogs up your nozzles, the water nozzles, the water jets, the water nozzles, the water hoses, and then the guy who sells you the equipment comes in there and says, I can't maintain this, I can't clean it. This won't work. You need all new hoses. It gets to the point that you need a water pump, a pump, I guess some sort of reservoir, and you need all the hoses and the connectors. You might as well just buy another machine.
Yeah.
So now you didn't clean it for 2 years or flush it out for 2 years, and now you got to go buy another $25,000 machine that probably would have lasted you 6-7 years, but you didn't maintain it.
Yep.
And that's part of the issue. I mean, another big thing is smacking around those C-clamps.
Yep.
Guys bang into them and stuff like they start smashing, or they drop it.
Yep.
That's the worst because they don't want to have one of these counterbalances. They try and carry them, or they drop it down on the ground. It's like, whoa, hang on a second.
Yeah.
Most of the electronics is in that thing. You don't want to be dropping that either. Better maintenance is, and that's why we talk about SOPs is, you bring the machine back, I got to sign it in, sign it out, and make sure I check it as, let's say, the parts guy or the foreman, and I get it from you, I make sure it's right. Or you tell me, hey, Larry, I got a problem.
Because usually
this is not working right.
The only time we know a machine's not working is when the tech walks to the front office and says, hey, it's not working.
It's not working, I can't work.
But there were probably 30 cars before that.
Yeah, but go mag weld it now.
Right.
Don't worry about it, just go mag weld it.
Yeah,
What happens if you do in a car that requires weld bonding?
Yeah.
Well, you can't mag weld that, because I'll tell you this much, you can mag bond it, I guess, because all the fluid's just going to leak out, all the adhesive's going to leak out, melt out.
All right.
So when it comes to the spot welding arms, it used to be more of an issue. This isn't really a maintenance thing, but when we used to have the old X arms, we had to use the shutters as hard as possible.
Those are the big copper-colored arms.
And we're not using those very much anymore.
You shouldn't be using that machine. If you have a machine that has those extended arms, like the PR10 was a great machine when it came out. It's probably good with the short arms, maybe to do a few rad supports that aren't attached to really ultra high strength steel, but it's probably great for restoration shops. But if you have the extended arms that you used to have to line up everything, the length, the width, and even the angle of which the tips matched up, and even how far the tips moved in and out, You shouldn't be using that machine now anyway. Mostly everyone's gone to a C-clamp design.
Right, and the biggest thing from a pre-weld routine is really using the shorter arms just because of ease of use.
Well,
I don't need a long one to put a rocker panel on.
The
versus
shortest
a rear body
C-clamp is the easiest. I mean, if I'm doing a rocker panel and you got the 300 millimeter, C-clamp, you're probably not going to get it underneath the frame machine and underneath the car to be able to do it anyway. But it's also a lot to move around. Sometimes you need 2 guys to hold that. You're better off with the shortest arms that you could possibly reach, just for ease of moving it, not so much power anymore.
So sorry, the tips.
Yeah, so the tip maintenance is a huge issue. So let's spend a little bit of time on that. Now this one here, I've got a little bit of adhesive on here. I got a couple chunks of steel in from my last repair on here. So that's going to require more amperage to make a good weld. The other thing that we see, so this one is a cap. We just take these off, put them back on, or we can dress them. So there's a little bit around, dressing the welds or replacing the caps. And this part, I want to spend a little bit to talk about the importance of having, because the machine will still make the weld. But what happens as shrooming get bigger, what we see is that there's more amperage required to make the same strength of weld. So this chart that we've got right here, so we've just got a 1/4 inch diameter, a spot welding tip. So when our amperage is set, we're getting 100% of that in theory. As it continues to get bigger and bigger and bigger, all the way up to a 1/2 inch. Now that's a lot, but we've seen it, right?
We've seen it.
We're only getting 25% of what that machine is telling us. So tip maintenance is a huge issue that we need to make sure that we're not only dressing them if the machine requires dressing, but we're replacing them on a regular basis, and we're including that maybe in our repair plan.
It's got to go in the repair plan. I think we figured it. You get about about 60 welds out of a set of tips, 60 to 80 welds out of a set of tips.
Generally, I mean, you can take a look at it a couple. You'd have to get used to how well you clean them in between each one, and what you're welding. Obviously the adhesive welding is going to beat them up a little bit more.
So typically, put a 1/4 panel on. How many welds are on that 1/4 panel?
Plenty.
Yeah. So I mean, honestly, for every repair, you're going to go through a set of tips, and that needs to become your regular routine. Whether that's your routine as a technician that you change the tips before you do any repair, or it's my routine as the shop owner where I change the tips once the welder's checked in and verify it's ready to go back out. But you're going to need a set of tips, and
it's a consumable.
Yeah, and I think Larry was the one that's telling me they throw because it's copper. They throw the tips in a bucket. And,
got a 5-gallon bucket.
And then go cash it in and buy lunch.
Yeah, we get barbecue one day. The thing you also got to realize about these tips, there's generally 2 different types of tips to make 2 different size welds. So make sure you have the right tip for that process. Never use a file or some sort of rotating air or battery type grinder or sander on the tips, because you can't form it the right way. You're going to screw the tip up. Use the sharpener they give you, and if you're going to use the sharpener, you got to be careful with the tips because it could spin off and go flying someplace like a bullet flying through the shop.
Is that happening?
It'll come off. So you got to make sure you do hold it the right way and you do clean it. The best thing I found seems to be emery cloth, and you just rub the emery cloth back and forth around the tip. On both sides and stuff, and I do it every 6 to 8 welds. Obviously wear a glove because those tips will get hot after a while. And just run it across it real quick, and the emery cloth works good. The Scotch-Brite pads aren't strong enough or coarse enough to really clean any crap off of them. You gotta remember, you do get sometimes bits of metal get stuck in there. So once a piece of metal gets on there, you might have to add a sharpener to it. But don't take a file and start sitting there going, okay, I'm going to be a file guy and I'm going to file this around you. You'll have all different angles and it won't line up the right way and you'll get poor welds.
All right, so let's dive into some of the OEM requirements. Let's start with some MIG-MAG requirements. Now, when it comes to shielding gas, aluminum's pretty standard, right? We're going to use 100% argon pretty much all the time.
Not too hard to order that stuff.
Steel, for the most part, we're going to be using C25, 75, 25. You may see some requirements or recommendations for 80-20.
I've seen 80-20. I've seen 65-35. I mean, there's certain little requirements, but it's very, very difficult for most of the gas companies to even get that for you.
And a lot of the times I think that's some antiquated information that's just kind of made its way from a save as over the years. When we're dealing with mild steel, we're dealing with thicker steel, so we need more penetration. Today, we don't want as much CO2 in there because that's going to increase the penetration and we're going to adversely affect the steel.
Well, we've thinned out the metal over the years. I mean, listen, if I'm doing restorations, I'm probably running pure CO2
You're doing a lot of restorations this morning.
It's that 70s Cadillac he's got, isn't it?
Restoration shops that watch this, so guys who do restoration work, if you're running restoration, you're probably going to run pure CO2 and an old Millimatic model with the plug in and out and the big huge dials on it, that's fine for that thicker stuff. Or if you're welding, if you have to weld a steel bed or some steel product, yes, that works for that. And it's a lot of heat.
But for collision repair, we're going to do 75-25.
Collision that you'll blow through that stuff, and that's been the issue.
And even if we don't blow through it, we're going to be adversely affected.
Yeah, you're going to screw a lot of problems. So you need the 75-25 mix to actually cool down the weld a little bit.
Okay.
Now, when it comes to electrode wire, for the most part, again, we're going to be ER70S6. There are some recommendations for ER70S3 that are out there from time to time. But for the most part, ER70S6. But again, we want to make sure if we do have ER70S3 requirement that we're swapping that. We just go like, well, it's close enough, right?
Yeah, no.
I'm only 3 away, right? So let's follow those OEM recommendations.
I'll round up.
Now, when it comes to MIG brazing, we may have some differences. There's a couple different MIG brazing wires that are going to be recommended. But again, following the OEM information, that's going to be right in the procedure or right in the OE information. Or see, we got the Mercedes-Benz information here from a class that you took here, so they're requiring CUSI 3 for welding on there.
That seems to be that's going to be the most popular. The CUSI 5, I think it is really, I've only seen Benz.
And we've got CUSI A here. All right, what that is? Yeah, well, regardless. Anyways,
which would be similar to which
we'll check before we weld.
Check before we weld, right?
It's similar to that
CUSI
wire there.
Yep.
The 5 wire is usually used for structural type welding, and that was with some of the European cars. I haven't seen 5 around in a long time on any procedure. The Honda wire that they came out with seems to be the new thing right now. You know, as far as the strength.
Now, when it comes to aluminum, now we got a little bit more difference here. Now we need to really make sure, because we're not, again, ER70S6 is going to weld all types of steel. But when it comes to aluminum, now we need to really make sure we're following those OEM recommendations.
You can take a steel mag welder and walk over to anything and probably weld it without much of an issue. You can take a MIG brazing or silicone bronze wire and basically weld any steel without much of an issue. And it's going to hold. It may not be proper, it may not be enough strength, but it's going to hold. Aluminum, you could take the wrong wire and it won't weld at all.
Yeah.
It won't stick. You'll weld it together, it'll look great, and then you go to move a clamp or something, and the 2 pieces fall apart. It's like, wait a second, it looks good. Certain wire will only weld to certain substrates and certain temperatures or certain materials for it. So you have to look up the repair procedure, and they'll tell you what you have to have. In some cases, like Mercedes-Benz proprietary, you just buy the Benz wire.
Sure.
They don't even tell you what it is.
Right.
It's just, this is for Mercedes-Benz, you put it on the machine, you use it for that.
The wire that shall not be named.
Exactly.
Now there's wire sizes, right, Jason?
Yeah, so the wire size, again, follows OEM recommendations. We can use a little bit of variance there from time to time, but I don't want to be putting on a truck frame rail with 023 or 024
No,
wire.
no, that you're going to be 030 or 035 in some cases. Off the top of my head, I believe GM and most of the Asian vehicles are 030.
But there's wire
Chrysler's 035.
size difference, and we got to pay attention.
Yep, exactly. And conversely, I don't want to be using 035 probably on a 6
And as
millimeter
an
plug weld.
estimator, I don't care.
Right.
It's not part of my research process. It's not part of the documentation.
Well, what's
I'm
part
gonna
of your
send back to
process
the car.
is the difference between
Right.
aluminum, silicone, bronze, steel, and
I just
squeeze
gotta
type.
know
What your consumables are for that.
Yeah, that's all I got to know.
Or how many different weld setups you have.
Rest of it is y'all's problem.
Yep.
Why did we invite her for? Why did we invite her for a technical
Because
class?
here is the misconception, right? The misconception is that if I have a research technician, if I have like an estimator or something, and I print or I do my Google Drive and have on my documents, that the technician doesn't do anything but review that and fix the car, and that's not true.
No.
Yeah.
And that's why shops that think, hey, I've trained my estimators, I've got a research. I saw somebody the other day post that they have a new job title. They're a research technician for a shop, and they think that they have a QC process. And all these shops that think that they've done everything that they've read in every magazine to implement, or a consultant has come in and implemented them, or they've been compliant with some OE's certification program, still fail when we audit the cars because there's a gap.
Yeah.
So
Yep.
the gap.
All right. So we've got all our machine stuff. We've got our electrode wire. We've got our shielding gas. We're ready to start making some welds.
Finally.
No,
Wait,
no, we're not even close to welding yet. There's more reading.
More reading.
But I didn't give you math this time.
No
You
math
guys
this
messing
time.
with my cycle time. I just want you to know that.
Cycle time is meaningless.
So the next piece we want to talk about is OEM weld joint configuration, because there's a variety of things here. I may have to do a butt joint with backing. I may be an open butt joint. Maybe it's a fill-in on lap, although not as popular as it once was. We're still doing some of those. Plug welds, we really start getting into whether it's a 6mm plug weld hole, an 8mm plug weld, or even some 10mm plug welds out there.
Depends on the flange size or what you're welding through.
Yep.
And even in some cases, it may be the only requirement in areas where the resistance arms can't reach the backside, so they'll make you do a couple of plug welds on a thing that has all resistance welds with 2 different configurations of joints.
So the weld symbols become very important. So I need to be able to access those weld symbols, because the weld symbols aren't always repeated in the procedure. It may just be the weld symbols. I need to go to a different document to find out what those weld symbols mean sometimes.
And so far what I've seen is every manufacturer is different. Outside of Audi and Volkswagen, which is the same company, everyone else has got a different, schematic or key to tell you what something means. Like outside of, I think a circle is basically the standard of a plug weld.
I don't know.
Oh no,
That's
wait, Mercedes-Benz has a circle that's a grayed out area, that's for resistance. Well, okay, now I can drive you in a wall. So you can't go with that either.
Yep.
You know what I mean? That's why it's very important that you read their key or their legend on what their weld parameters are and what their little hieroglyphics mean.
Right.
And even when it comes to MIG brazing, I may be doing a slot weld where I'm just welding along one flange, or we'll talk a little bit more about the Honda kind of dual plug weld hole and their zigzag pattern here momentarily. But again, it's really important to understand what those weld symbols are and what that vehicle maker recommends, because not everything is. There's no universal plug weld size. No. There's no universal symbol for anything, so it's really important that we're following these, and we're going to kind of dive a little bit deeper on a couple of different vehicles.
There's no universal technician. Oh,
no universal technician. Okay, so let's dive a little bit deeper. We're going to use Honda as an example, just to show you what Honda's got for some available information, and Fiat Chrysler's got for available information. And again, the OEs have varying requirements, and we're going to talk a little bit about what we're working on to help address that here just a bit. So one couple of great documents. So if I go to they've got a collision repair information and industry position statements part on their website, which I think is fantastic, because they got a whole bunch of stuff right in one spot. You have to go into each OE or each vehicle to find these procedures.
Yeah, I'll say if you get it wrong on Honda, then you got
you're not even trying.
Yeah. They've done a really good job.
So the first thing I want to talk about is when it comes to, they've got one document that kind of gives some general overviews of sectioning and the requirements that goes through a whole bunch of different information, including the different types of welds that you may see on different types and thicknesses of their steels. So I think that's a great kind of reference document. Again, it doesn't really tell me the procedure, but it kind of really sets the stage for what am I going to have to do on these particular vehicles. So it's a great reference document to kind of start with. In that chart, they've also got this weld parameters chart for spot welding. Now, I think a lot of times people think like I can just turn the machine on, make the weld, and I'm done.
I get a green check mark or a woohoo when it's right?
Exactly, and then I know I'm good.
Yeah.
These auto machines can be misleading. Unless you're just welding the same area, same spot on a vehicle that only has. That has, it's just one setting for that. With Honda and some other companies, you have these multiple settings in multiple areas.
How many are there, Jason?
There are 31 different spot welding parameters from Honda
31.
That are available, yeah.
And I remember, so it was probably even more than a year ago, we had the 3M guys down here, and we were doing that B-pillar on a Honda, and there were just alone in that procedure 5 different spot weld parameters that Sean and Dennis were having to, okay, now I got to go reset the welder. And you had to really plan. So I was watching Sean draw on the part so that he knew, okay, when I get the welder set with these parameters, these are the welds I can make. Yeah. And then I got to change parameters, and now these are the welds I can make.
That's the easiest thing to do, is mark it off on the car.
Yeah. It's fascinating.
With either different colored tape, or I think just the markers work great on there, just to show what I'm doing here, what I'm doing here. And what you can also do is, once you see the markers on there, it's like, let's say I got a green marker is telling me it's this setting, green marker is this setting, green marker this setting, and then I got yellow and pink and pink. Well, I can do my greens while I'm switching the machine up. It's cooling down a little bit. I can go back and do my yellows or my pink areas that I set up with my crayons.
But that's a fantastic call out to say, hey, even within the same OE, I may still have to set this welder up 5 or 6 times.
Same OE, same car.
Yeah. Same car.
Not different vehicles. It's the same freaking car.
Yeah. So let's just look at this rocker panel on this particular vehicle, okay? There are 3 different spot welding parameters, and what is that, like a 2-foot section, 2.5-foot section?
Yeah.
There are 3 different spot welding parameters just on this rocker panel alone. We've got, looks like we've got, what, 3 of one type, a handful of the other, and a couple of a different welding parameter. So again, just on that rocker panel, I'm gonna have to make 3 different settings. But wait, there's more.
Oh wait, there's more.
On the same vehicle, towards the front of it, or at the bottom of the A-pillar, now we see another symbol in here. So again, we got to go back and reference our symbols that we talked about earlier. And this particular symbol right here is the indication for a MIG braze weld from Honda.
I thought that's no parking. Isn't those little hash lines say usually no parking?
So in this vehicle, well, I also see I've got some plug welds, it looks like there.
And you got
maybe
some bolts
as
in the
well.
front there
And we got some
that
bolts.
they give you torque specs for, and the size bolts. So you got a lot of stuff going on.
There's a lot going on here.
There's a lot going
here.
on between this spot here and the spot we saw before. You're at 8 different things you're doing, and 6 of them are just some
again,
sort of a.
this is not what my estimator is going to
Right.
do. This is the extra step that now the vehicle has left the blueprinting and is in the technician stall. This is what I am expecting my technician to do.
And we're calling this a pre-weld routine. I
It's a
shouldn't just
pre-weld
go like,
routine.
okay, well,
We still haven't
let's-
welded yet.
Let's pull the machine over there and let's just go. I've got the
Yeah.
procedure. No, let's look through the procedure. Let's analyze it. Let's think about all those different things I need to do. Let's think about my different weld settings and where I'm going to mark everything. Make sure I've got my MIG brazing wire. Make sure I'm ready to go on it. There's a ton of stuff that needs to take place here. So we may have some plug welds on this one part. Plug welds, MIG brazing, 3, 4, 5 different spot welding parameters. Weld bonding applications. So again, there's a ton of stuff I need to do here. And if I'm just, running around and grabbing things each time I need it, that's not an efficient repair
Somewhere right
process.
now there's a Honda certified shop going, wait, I got to go to the shop.
Thank God they're taping this. I'll go back and watch it later.
And so we want to talk about the MIG brazing requirements for Honda because this is a bit unique. So some vehicle manufacturers have a slot weld where we've got an elongated kind of oval hole that we're going to make a weld or a MIG, I should say weld, a MIG braze joint along kind of like the top of it to give us that surface area. And Honda, on the other hand, they require these multiple 8mm plug weld holes essentially that we're going to use a zigzag pattern, and that's what the Honda recommendation is, using pulse.
It's like a drunk weld.
A drunk, yeah.
It would be a bad
Hey, can
weld
I
if it
do
was
that
steel.
one?
Yeah, that you could probably do.
You bad weld if it's steel.
Yeah,
it's a good
she
weld
could
of
probably
MIG
be
brazing.
good at that type of
those.
weld
Yeah.
because I've seen her welds. I'm getting her a grinder for Christmas.
I can't get him to hold the grind. That's
You know,
what I mean.
the funny thing is that it shows you don't make a figure 8. You don't overlap it this way. There's a certain amount of space in between the holes. You got to leave a little bit of metal in between there. It's not technically a figure 8 or an overlap where they connect. They're actually separate holes. They're probably very poor plug weld holes because of the fact they're so close together, the pitch between them. But the pitch between them is important to keep that certain amount of metal in between, and then you do that zigzag weld back and forth. And this is what Honda's, their engineers, they researched, they figured out this is what we need for this repair versus Mercedes-Benz has a tool that punches an oval shape and you weld just one side of it.
Now-
It depends on the company.
Here, the one thing that I want to keep in mind, there's not an engineer sitting somewhere over in Japan going, let's come up with as many crazy different ways as we can to put a part on.
I think they are. They're like, we watch Collision Hub. We're going to make them crazy.
Right. Now, if you're talking about some of these components, this is where my energy transfer takes place, right? So these different welding strengths, sizes, techniques, etc.,
Materials.
are what they've discovered has to be done to keep the energy transfers going the way it needs to be done. So it's not optional, and it's not an OE they've never fixed a car before. They don't know how this really works. They would really love to make it as simple
I
as
love that
possible.
statement.
Right. But there's some reasoning for this. So I think sometimes we see these things and we go, yeah,
Right.
right.
Yeah, there's
I
definitely
know
a reason
better.
for
I've been
it.
doing this 30 years.
Here, hold my drink.
Hell, my drink.
Okay, so we're going to come back and talk about the MIG brazing just a little bit to kind of close up the part of this Honda piece. But before we do that, I want to talk about this other high strength wire that Honda has available. So they allow
We're in
conventional.
something else now?
Yeah, exactly. So they allow conventional, ER70S6 up to a certain strength of material, and then there's a range from their high strength steel. They require a high strength steel wire, which can be a challenge to get a hold of. So now, if I'm from a planning and preparation standpoint, if I know I've got a Honda vehicle coming in, and they use this quite a bit, so I need to make sure that I've got that electrical wire in my possession.
There's certain parts that you can't weld with anything else but this stuff. There is
Right.
no option. It says only this.
Yeah.
And I can't just run down to my local welding supply company and pick this
you're
up.
not gonna
I'm
get
not
it.
going to get it. So they've got some requirements. There's a couple of different vendors that make this available, but it's important to have that on hand if I'm doing a lot of Honda vehicles or any Honda vehicle.
And again, Honda has done a great job with the information. There's the phone numbers and everywhere
Yep.
that you can call
Yeah,
to get it.
there's three suppliers for it. You should be able to get it pretty well if it's in stock, which
If
most
it's
of
in
the time
stock.
it is. You know what you said.
You don't have an excuse.
Yep. So take that a step further. So now another thing that Honda has that I really like is these body repair news articles that they come out. So when they release a new model, they've got a great resource that gives you kind of an overview of the vehicle, where different materials are used. They used to have that MIG brazing information.
Jason, these are available for free, correct?
A
to have
lot of
the
these are
paid-
available free, yeah.
Okay.
Or you can purchase them more from me if you call my cell number. I'll be more than glad to sell them to you.
Well, you should, and quite honestly, right, you should be buying the access to the Honda service information
should.
anyways.
But
from
I
a
think it's
repair-
another
from a
step
planning
that
step.
Honda's, some things are available, a lot of information is available for
Yep.
free.
When
before
they
you get to the
come,
paywall.
usually when they come out, I've been seeing that Repairer-Driven News usually
article. Yeah.
usually puts out an article. Hey, Honda just came out with this and gives you a link to it, at least for a little while, or if it still stays for free. But at least there's a new the one news agency we have for it will actually tell us,
Yeah.
hey, look, they came out with something new.
It's really a great resource, and it's one of those must-read things when they do come out. Now you can see on here anything that's red is 1500 MPa steel. Now I know from my research that 1500 MPa steel is going to have some different spot welding variables, and I know that those areas where I can't reach with my electrode tips, I'm going to have to do that MIG brazing. Now this is a Honda Odyssey. That's a pretty big door ring there, but they're using this on everything.
It's a lot of places.
My point there is essentially like if you're doing repairs on a Honda vehicle, you need MIG brazing equipment, you need MIG brazing wire, you need to have a machine that's capable of the different spot welding parameters. If you don't have that, you're repairing Honda vehicles incorrectly.
More than just having the equipment, you need to know how to use
You
it.
need to know how to use it as well.
Because I
yes.
go in a lot of shops that have the equipment. They've met
Sure.
some sort of criteria. They get a check in the box, but I can walk over to it and go,
Yeah.
Well, I can't
That's
just
a whole nother
Yeah.
show.
I
yeah,
can't
right?
just squeeze that trigger on that machine right now, and it doesn't do this like like it's like a missile from a plane
Hey,
and just flies over to the
There's
car
no
and just
easy,
welds.
no easy button.
Oh, I thought there
I'd
was.
take at least the trying to squeeze the trigger and not do the setup right if they at least try to squeeze the trigger, but it's over in the
Yep.
corner, never touched.
Okay. All right, let's switch from Honda to Fiat Chrysler a little bit and just kind of show you a couple of different things that Fiat Chrysler has. And again, other vehicle makers have very similar information out there, just laid out a little bit differently. But we've got one kind of weld process chart. So Fiat Chrysler tells us about the different materials that you might be using for electrode wire size, for electrode type on their vehicles. Now, this is general information. So this is not in a procedure. But I found this from Fiat Chrysler. Note OEM panel replacements such as quarter panels, there's a few of those, side apertures and rocker panels will always require the weld bonding procedure at the pinch weld flow. So again, there's something I need to think about as I'm building my repair plan, that okay, it's a Fiat Chrysler vehicle, I'm putting on a side aperture, I'm going to be in a weld bonding situation, I'm going to need adhesive, I need to prepare for that, not just when I'm ready to work on the car, but well in advance of that.
But now what I'm also hearing you tell me is that my welding requirements and parameters aren't going to be in the procedure. I gotta know that I gotta jump somewhere else and do some more research.
Well, if
it's not
anyone had a
hotlined,
class on that,
right?
on how to research that.
It's
So
on me, right?
multiple places to get the information. I need to do one repair. Got
And
it.
here's another general procedure here from Fiat Chrysler, just kind of talking about the last part here. Vehicle design will determine if the section location is in the pillar or roofline area. Reference the vehicle specific body repair. So again, I can't just build and repair the car, found the general information. This is good information to have. I need to know all of it, but then I'm going to need to follow it up with the actual OEM procedure itself for that part. Now let's talk a little bit about weld through primer, because here's another area where we don't have uniformity from vehicle maker to vehicle maker. Fiat Chrysler says weld through primers are not recommended anywhere spot welding or mag welding is used. So if I'm welding on a Fiat Chrysler vehicle, no weld through primer. If I'm welding on a GM vehicle, you'll often see prepare the flanges with
Right.
weld through primer. And just to clarify a little bit on weld through primer, that doesn't mean you're actually going to weld through the primer. I think it's not the best name for it. We're going to clean out that weld area, and it's more like weld around primer.
It's the
weld in
area.
between
If
primer.
you have this gray panel here, and I'll choose the white. My finger,
a
the
big
round
plug
circle
weld.
there is the actual plug weld. This is my weld through primer here.
Yep.
I'm going to take a flat bottom drill bit or a little captive sandblaster, and I want to blast this out and get this area to look
back to bare metal so that my weld is proper and my weld will adhere properly.
Now you'll have-
And that's a big mistake a lot of guys make, and that gives an issue with welding. If you actually lay two pieces over, you want to sand in this area here with a wire brush or a piece of sandpaper to clean that out and get that back to the silver color. So when you weld, the white being representing the weld through primer stays in the background and adds a little bit of corrosion
Now we have
protection.
some OEs that'll tell you to use it if you're doing squeeze type, but don't use it if you're doing mag. So
Again,
it's 100% of the time I got to read and decide yes
Yep.
or no.
Squeeze
So-
type will work a little bit easier. Mag, it'll mix in with the weld as it melts everything, and it becomes an issue. It actually contaminates
My
in some
estimators
cases.
pay attention to that because if you get in the habit of doing that lanyap list like we talked about last week, where you get to the bottom and you go, oh, I'm welding, and you just start clicking and adding stuff, and someone like me comes along behind you for an audit, maybe you're in an issue with an insurer, maybe we're heading to court, maybe we're heading to RTA, whatever we are, and I know that you shouldn't have done that, it just doesn't look good.
I love when you see like a weld bonded procedure, like on a Chrysler, and they're doing weld bonding, and then there's the adhesive, the tips, and weld through primer. Doesn't work. You can't do it.
So, we're real to kind of close the weld through primer, or not close up, but to talk about we still see a lot of questions on one particular topic. Can we just real briefly go over the list of OEMs that have approved copper weld through primer?
I gotta remember
I'm going to
back.
go for zero.
Zero always.
Jason.
Okay, so if it
Zero.
says weld through primer, they're not talking copper weld through primer. We're talking about zinc rich copper. So, a great resource to find out if the vehicle makers, in general, again, we want to make sure we're still going the OEM procedures each and every time. But the ICAR RTS team has put together a nice article on weld through primer guidelines, as well as links to a ton of different vehicle manufacturers for whether they do or don't, or what they say about weld through primer. That's a great
more reading.
research. What's that?
More reading.
Right.
Yeah, so go to RTS.
Can't I just press a video and have them tell me?
But like we say, like we've been saying for the last couple of years, I start every morning with the ICAR RTS portal. I'm looking for a new article. I'm looking for anything that they've updated, and it's an invaluable tool as an estimator. And I'll say to the insurers, I agree. I would not buy OEM repair access for every one of my estimators. The financial burden on that would be too much for the company. But RTS is something right now is free to the end of the year, and so it's a great tool for if you're an independent adjuster, whatever you are.
And this is an article, so it'll be free even after the
Yeah.
first of the year if they go back to the gold class and platinum requirement for it. Okay, so a little bit more on Fiat Chrysler. So they've also got some information on their modified overlap joints. So again, how to make that when it's called for in a procedure. A little bit more detail on that. And then we're going to get into, so these OEAs are going to, this one is a great one. I like this one because Fiat Chrysler is telling us to do some test welds. Now, when it comes to test weld, Kristen, I can just use anything I got laying around the shop, right?
No, not at all. I got to use the donor material
it's
off what
steel.
I'm replacing. Yeah, and it's a lot thicker. So it's different metal types. So no metal is metal. Every OE has their own proprietary metal. I mean, Toyota takes it so far to say our metal's so special, I need epoxy before filler. So everybody's got their own special metals with special treatments. Nothing's steel anymore. It's all something made in a lab almost. And so just to go pull some coupons off the floor or out of a box and go, I'm going to test my welder, isn't matching what you're actually going to do on the car. It's not the same material. It's not the same chemical makeup. Right? It's not chemical's not right, but I mean it's not the right makeup.
Well, it's a chemical
Yeah,
makeup.
sure.
So
Yeah.
I've got to go take the donor part that I took off. Duh, you're replacing a part, you're welding.
Yep.
So take metal off the part you took off and make your test welds from there, but then also think about your test thicknesses. What else am I going to weld through? And so that's when usually people go, well, how do I do that, Kristen? Well, because I save stuff, right?
Right.
So I have bins, little Tupperware bins that have different metal ratings, and sometimes it's inner structure and high strength steel
Yep.
because if I'm going to put that rocker on, I'm going to be welding
what I'm gonna be
sometimes
welding
through
on.
3 and 4 layers.
Yep.
And I've got to recreate that to know whether that welder's right. And if I'm not, then I'm not repairing right, which then brings you back to a failed reinspection by one of us.
Another great resource, so you mentioned the part I took, the donor car, the part I took the vehicle off. The other part is if I buy a side aperture, for example,
save that.
I'm only putting a rocker panel in or a B pillar or an A pillar. Like, take that, cut that up into some pieces, mark, hey, this is off of a 2020, such vehicle. Put that in your file so that when that next vehicle comes in, I've got that material. Like, I can also use it in practice in between if I
Yeah.
want to keep my skills polished.
Don't let it head to the scrap. So a lot of times we pull off parts and we immediately think I'm going to go chunk that in the metal scrap bin and somebody's going to come by and pick that up. It is a great tool for you to have young technicians, kids from the tech school. They've got to get used to cutting these parts apart And this is a great way. They don't get a lot of late model salvage at the tech schools, but a lot of times if I save those parts and have them come by and say, hey, harvest some metal for me, it's just good learning.
I have a Honda shop that, you know, has some young technicians that come in. He did the smartest thing in the world, because to make practice welds on the Honda, you don't always have inner structure parts. You're not going to get them that much, because if you get that far into the repair, it's probably a total loss in many cases. He bought a unicide from the junkyard, whole half a car, you know, from the front to the rear. He says, just cut the car in half. Well, the other side's wrecked. I don't care.
Right.
Just cut the whole side. Then he had the techs that are trying to come into the shop, the newer guys, and he had them drill out the unicide so that they once again wouldn't drill through the inner parts. Now he has a whole unicide off, and he's got a body in white basically now. And you know what he does? He has all little spots that are all practice weld on there when they have to do resistance welds or plug welds or boiler welds through the thinner outer steel, you know, the mild steel primarily, or the low strength, high strength steel, onto those advanced high strength steels, ultra high strength steels, structural inner components, reinforcements, and these kids get to learn you know, how to drill things off without damaging a car you're going to fix. And it wound up working out really, really good for him. You know, so it might be an idea for shops out there. Buy a unicide, put it on the side there, and let them practice and drill it out. You know, it's the only way you're going to learn how to do it.
Yeah, practice.
And how do you practice welds on inner structure stuff that I don't have it?
We don't practice on customer cars either.
Right, yeah, well, that's why you don't want to do it. That's why you buy a scrap piece.
All right, so let's talk a little bit about OEM equipment requirements, and this is an area where it's confusing. You know, it's confusing for us, I think, as far as the types of machines the OE requires. Is that going to be a specification-based requirement for a spot welder or MIG welder? Is it going to be, if I'm part of a network, that might, so the network requirements may say, you know, you need to buy this machine. You have to buy this machine, but that doesn't always mean that I can't use a different machine if I'm not part of that network. Again, it's very confusing, but let's talk a little bit about some of the different requirements between it from different OE perspectives. Now, Fiat Chrysler, back to Fiat Chrysler again, they've got weld parameters that they say, you know, you need to make sure that you've got the amperage required to make the various welds on the vehicle. So depending on the thickness of the material is going to dictate the amperage, which is going to dictate the machines that are applicable for that particular vehicle.
And this is a good place to add that this is also where I run into a lot of shops that are making welds with the wrong equipment and thinking they're okay because they're like, well, I'm not certified. I'm not on that OE's program. You didn't meet the minimum requirements.
Right.
And therefore, none of your welds are good.
Yeah, there are minimum requirements, and there may be instances where, again, if I've got the equipment that's capable of making but I'm not part of the network, there might be some variables there. But again, those requirements that the OE has published, they know that those machines are going to work, and we'll show an example of that here. Fiat Chrysler goes on to say, you know, when it comes to GMA MIG welding, that 220 volts would be kind of the preferred minimum capacity for a welder. So again, just following that OEM information, make sure that you've got that at your fingertips to know what you're welding on. Now, GM for spot welding, they again have done the research, and they have a list of, they say that equipment that is most likely to meet these requirements, and they've got some equipment required. Now, it doesn't mean you have to have one of these brands to weld on GM vehicles. They just know that based on their research, they know these machines are likely going to, these work. Then you start getting into, you know, the German car companies, and again, it's going to be very specific, where it's going to be a VAS number.
There's like
even
two or
to
three
You must
options.
buy one of these three welders to be on our
And
program.
here's an example of that. So Porsche, for example, they are listing out specific makes and models of welding equipment for their network. Audi, Volkswagen, same thing. So again,
And it can be a little difficult with them because a lot of times they'll just give you a VAS or a VAG number.
Right.
And you're like, that looks like a pro spot. Well, that looks like a car line. And you really got to kind of look into it to see who makes it so you can figure out which machine it is. And you might have to call that manufacturer and say, hey, what machine is made by this? But if you're on a Porsche, Audi, Volkswagen program, especially
you're going to need that VAS
Audi and Porsche, you have to buy that machine,
Yep.
which may be accepted by, let's say, Mercedes-Benz, Land Rover, Jaguar, or one of the other programs, or may not. So you really got to check into that and try and pick the best machine that'll cover a bunch of companies, you know.
All right, so let's talk about available OEM weld training that's out there. So there's some different welding requirements for training. GM, Ford, Honda, others have kind of a, they require the ICAR welding test for a lot of their programs. Toyota's got their own welding training program that they, because of their proprietary steel, they want you to come there and learn more about how to do it on there.
It's a really good training program too. I've been through it.
Audi's obviously got their program. We've got Larry's Mercedes-Benz training here. I was looking through. You got a lot of good notes.
Does he have any notes?
Well, this one doesn't have as much notes, but this one here, right here.
Oh.
Look at.
Oh, wow.
He's got
like a good student.
penmanship
Hey,
too, doesn't
what?
he? So then you just went back. You just at Mercedes-Benz not
I
long
was
ago doing
there
some weld training.
3 weeks ago. Yeah, to go to Jersey to do the. They actually moved it to Jersey to take care of some of the shops because of the restrictions of travel with the Northeast states and what seems to be the rest of the country. So we couldn't go to Texas, so they had to kind of make it go up there so we can at least get some of our welding. We actually had to take 2 tests. Technically, because we were behind on one because of the COVID. So some of us had to take or actually submit, 2 samples for one test and 2 samples for another test. So now you're like, oh God, and they got to be shipped to Texas.
Yep.
So we don't know if we passed or not. It's not like being in Texas where they actually test it right there and then. So a little on edge.
So the weld training it can be a challenge right now from the OE perspective because a lot of the training is shut down. But Kristen, you've been doing some research over the last couple of years, and you've discovered some things, and we've come up with a solution for it.
Yeah.
And so now's the announcement
time, the drum roll, right?
Yes.
So we spent 2 years. Jason spent a year on this project with me. I spent a year looking at it ahead of him. And here was the problem. We have never had at our fingertips so much information as we do now, and we're still doing it wrong. And we're doing it wrong over and over and over. And this isn't about something that we could say, well, I'm not getting, the insurer doesn't pay me for this, or I don't get compensated for that. If you get 14 hours to put the quarter panel on, that's the book time. That 14 hours is to put the panel on properly.
Right.
So we had this gap. There was this gap between information being available. Over here, I'm individually training technicians and working with coupons. Right? That's my Canadian, right? So I'm working with the coupons and they're welding, and then we'd come back to the middle and we were still getting it wrong. So the shops we were inspecting were not untrained shops. They were not backyard shops. These were high-end, well-trained, had been to everything that they could go to, and it's still wrong. And so what's the gap? So Jason comes on and we start talking about the gap, and well, I think we solved it, Jason. So
we did. So what we're going to do is we're here to announce today the release of an OEM-specific virtual welding training, coaching, testing program.
Yeah.
So we're going to get a little bit into the details around it, but this has been an exciting project for me to work on. I think it is desperately needed. We just went through all these OEM procedures, right? And you saw so many variables in there. So we wanted a way to, number one, teach technicians where to find that information for each different vehicle manufacturer. And number two, train them on how to make those different welds, because if I'm working on a Toyota vehicle, for example, there's no reason for me to do a butt joint with backing, because I'm not going to do that weld.
Right.
Conversely, if I'm working on a vehicle that doesn't have an open butt joint like Toyota does, that really should be maybe part of that OE specific training.
Or a lap weld type of weld.
Our European certified program, so what Larry was doing, and one of the things that we didn't have the problem a lot with these shops was that when you went to OE training, they taught the technicians how to do the research.
Yep.
The research is required in the certification, so the technician has to prove they've done the research in the file to stay compliant with the program, and then the technician has to apply it. So that's really what that bridge in the gap is okay, this works.
Yep.
Let's take it, Max.
Well, every training class they make you as a group, like me and Chris would have to look up the B-pillar replacement
Right.
and then explain it to you guys. And then we got to physically do it. That's
Yep.
part of the program.
Right.
The welding training program, the welding test, you don't look up anything. You go in there and you just do your welds. That's
Yep.
a test. But that test, along with the physical hands-on welding in
Put
the
the two
thing
together.
and looking up the procedures,
Right.
encompasses everything together.
But we can't be physical and hands-on and still be. It just doesn't work.
Right.
So for mass amounts of OEs.
It
so.
doesn't work.
Right, it doesn't.
Yeah.
So we've got a basic online, we're going to talk a little bit more, basic online course, OEM specific online course, coaching, and then a test that we're actually do the OEM procedures. And so this is available right now on the Collision Hub website.
Launched today. Actually, launched yesterday.
Launched
because I was afraid I wouldn't get up this
Did a
morning.
soft launch yesterday. So this program for one OEM $449. If you want to add a second OEM, or maybe you don't pass the test the first time.
If you don't pass, and this is not everybody passes.
It's not everybody
Yeah.
passes. So what we're going to do is, after we go through the online program, we're going to do a virtual coaching session
Yeah,
with the technician.
So the online program, once you sign up, and it's per technician.
Yep.
So once your technician signs up, your technician will can at that time choose the OE that they plan on focusing in. If you don't know what OE you want to focus in, that's fine. We'll get with you after the coaching session. But you are going to take an online series of, is it 12 or 13? Or it's more than that. It's like 16.
There's 16 different modules.
There's
Yep.
16 online
Short
modules,
modules.
very short,
Yep.
couple minutes each that the technician has to go through, and it covers a lot of what we covered today.
Contact tips, electrode wire, turning the machine on, reading the charts.
Right, so we want to know that you're up to speed on that with your welder, and you're going to tell us what your welder is too, so that when we get on the line with you for your coaching session, we're ready and prepared as well. And it may mean one of our coaches is better with Miller, while another coach is better with ProSpot, et cetera. But we're going to match up the coach with the OE and the welding equipment. And then one of the coaches is going to call them for this virtual session that you're showing.
Yep. And so what we're doing, then we also got, we're going to have wireless headphones.
Yeah.
So we can watch that technician weld via Zoom meeting. We're going to send you a stand, so you can put the stand on there, mount your smartphone or your tablet on there, so we can have two-way communication. I can see you, you can see me, and I can talk to you. And we've tried this with a couple different shops during our beta testing. We can communicate. I can talk. You see Kyle here's made some plug welds. We were talking during it. I could tell, hey, it looks like you're going a little bit too slow. Looks like you're going a little bit too fast. Like, let's turn. I could see the backside of his welds and go, hey, let's turn that machine down a little bit. We walked through the whole settings. We went through the whole process, and it worked great.
And I love the screenshots from it. So the holder arm that's holding your camera, basically your phone, is probably, it's at least this long. It can clamp anywhere. You can turn it, move it. You know, you could clamp it to a B-pillar if you wanted to. You can clamp it to your welding cart like we've got there. So we're watching the technician work. They're in their headphones. Jason, you're talking to them the whole time they're welding and working. That's a picture showing us the welds.
Yep.
It's very much like we're there and coaching you through the entire session.
Yep.
Right? Now, at the end of this session, you're going to tell the tech whether he's ready to go or whether he needs more work, right?
Yep, that's the plan, yeah. So again, if we sit with the technician and go like, you know what, I want you to practice a little bit more. Let's practice for another week or two, and we'll come back. Because we don't have to really physically come back. We can do another Zoom meeting, make sure that you're ready to go. But if I watch a technician and say, you know what, and I did the beta test with one of the Blazes technicians, and it was apparent, pretty quickly that, okay, this guy's dialed in. He knows what he's doing. We can jump right to the testing phase and say, okay, I want you to get the parts ready that you're going to be welding on, and let's jump to the testing phase. Now, when it comes to, here's kind of an overview of it. So we talked about the online basics course. We're going to have the online OEM course that, again, is going to kind of go through a lot of information that we went through today. Like, where do I find this Honda information? Where do I find this Fiat Chrysler information? And train you how to use the OEM information specific to welding. So not using the overall service information, but specific to welding.
So that's that gap between here's what I got to do as an estimator to write the repair plan, but that doesn't mean that the technician doesn't have a role. So now here's the gap in teaching technicians how to go to the 3 or 4 places they need to know how to put that rocker on or whatever.
Yep.
Okay.
And so then when it comes to the actual virtual testing, now what we're going to do is we're going to tell the technician, okay, they're going to be a form there to fill out. Say, okay, I'm going to be making I'm going to be welding on a Nissan Sentra rocker panel. They need to go find that procedure, identify the material type and thickness of that identify the joints that are going to be required for that vehicle manufacturer, the plug weld sizes, or whatever GMA MIG welding. We're only doing the MAG welding to start with. We're not doing spot welding. We're only talking, and we're not doing MIG brazing to start with. We're just doing conventional MAG welding on this. But they need to find all those OEM procedures and show us that they indeed pulled that procedure and says, hey, today, it's like a cooking show. Like,
right.
Today I'll be making a open butt joint and a 6mm plug weld. So they need to validate that they've done that. So we're going to be using this on OEM material, so we're not going to be using coupons. It needs to be those donor vehicles or that part that I pulled off.
So now they're showing us that they know how to read and interpret and explain to me the procedures.
Yep.
They're going to be able to show me that they've actually got everything they need with their welder, the right gas mix, the right wire, they understand rollers, they understand all that. And then they're actually going to have to make their weld testing material out of the real stuff. So now they're going to be able to prove to me that they know how to make a test panel and do tear outs and everything.
Yeah, and we're going to visually inspect it, destructively test it with them right there. Make sure that they make those required welds. And if they're not successful, they're going to need to go back and practice. We're not just going to say, go do it again, go do it again, go do it again. We're going to have them practice, and we're going to come back, and when they pass that test, we're going to feel comfortable that we both know that they passed that test.
Right.
The other thing we're going to do is these will be Zoom meetings. We're going to record each session. We'll upload them into a file so that, number one, we can audit that shop if we need to. If someone says like, hey, are you sure about that? Or if we need to audit one of our coaches, we can go back and say, you know what, we're here, Larry's letting some things slide over here. Let's go look at the footage. We'll be able to go back and take a look at that. So again, it's a kind of an audit validation process.
It's transparency.
Yep.
I mean, completing the process. So I mean, I want to know if to do all this, obviously you two guys can't do it all, right? So if we add other coaches and somebody tells me, or I hear that rumor that these things aren't real, Chris, and they're letting people go, or I hear a rumor that your coach sucks, right? Which could happen. I'm going to go back and pull that tape and watch it. And if I don't like what they're doing, then they're gone. Because I mean, this is life. To me, this is life death.
Yeah, we're not going to do rubber stamping.
I love that transparency process. Now, people ask me, Kristen, what can you really see through a camera, through a cell phone? Well, that's a great picture. I mean, that's almost like I'm standing over his shoulder watching him do these welds.
That's a screen capture from Zoom.
From Zoom.
And then he took the camera. I can see the back side of it. He brought it around. We can see the front. We can measure it. We can look for that penetration. We can put it in a vise. We can do that visual inspection, destructive testing. And again, we've got that documented. And I'm super excited about this.
Well, to me, it's the gap. It's everything that was failing in the whys when every shop thought they had it. Now we're really focusing on the technician actually, not physically pulling the trigger and can you make a weld that passes on a coupon, passes a test. That's very important, and that's the pre-training you need to have before you get here. But now I want to know that you can actually do the specific weld on the specific material with the specific equipment that is required for this specific vehicle. And those are the big gaps. I mean, if I think about my technicians, we got into this field because we didn't want to sit in a classroom, and we didn't want to read, War and Peace, and we didn't want to do all these things. We wanted to work with our hands. And now this job has very much become a reading and research job. It's almost separate from what it was 10 years ago. And we've just left this gap, and these technicians are standing in the middle of the shop going, well, what do I do now? Right? Now that it's a Toyota and tomorrow I'm going to turn around and it's a Honda, what do I do now? And I think the European OEs have somewhat solved that because of the way they train y'all when y'all go in for welding testing. They make you do the research. And it's not feasible for some of these other OEs to do that same thing. This fits the gap. And I'm super excited about it.
I am too, and I know that we've got people watching online right now. They're thinking, yeah, but what are the OEs think about this?
I don't care.
We've reached out to several OEMs. We've had a handful of meetings already. They really like the fact that it's a couple things. They really like the fact that it's it's on their vehicle. So we're welding the material that's actually on their vehicles. They really like that part of it. They like the virtual part of it and the recording, the ability to audit it. They also like that we'll be able to assign instructors and coaches to equipment because you don't want me doing the Fronius stuff. I want Larry doing the Fronius equipment, and where I can handle the Miller equipment because I'm more familiar with it. We can go into the shop and say, okay, what equipment are you using, so we can assign the best coach for it.
We're looking at a lot of stuff. I mean, being able to assess the quality of your welder and is it maintained and are you ready? Right. And there's several times when we started this with test shops where we got on that coaching call and we went, "You're not ready. You're not. I mean, we can't even get started because your equipment needs to be completely reworked or overhauled before we can get there." But it just is fantastic, and I've watched some of these replays, and man, I love it. I put my management hat on, and I know it's different managing DRPs versus managing certified shops, but there's a whole lot that I have to take for face value when someone, I had this great service for my DRPs where the shops would upload pictures of their lobby and their bathroom and their parking area and whatever. But it just wasn't the same as watching them work and to be able to go in and hit a button and go, oh, I can see that weld. Now, if I'm a shop owner and maybe I even have multiple locations, this is a great way for me to know how my techs are really, truly performing in their daily jobs. Can they really weld? So there is a lot of give in some things. This is one thing that's not a lot of give. And we're going to identify what the weaknesses are. So you may have a technician that's a fantastic welder, and I may be able to send him over somewhere and have him perform a weld to be tested, and he'd pass every time. But he's a horrible researcher. And then that means he can't apply things to the car. And once we identify what his weakness is, we can fix him. Right? And then that means we're going to raise the repair quality across the board.
So it's available right now.
Right now.
You can go to collisionhub.com, click on the store link, and then click on the training link. There's the long URL right there to get to it. Once you make that purchase, we'll be in contact with you to kind of get you set up and walk you through the initial LMS process part of it, and we'll start scheduling that coaching session. I got a hunch we're going to need some coaches pretty soon. So if
we are going to need some coaches.
If you're interested in that, feel free to email me, jason@collisionhub.com, and we'll start that process.
Yeah, don't email me. I wouldn't know if you're a good coach or not. So, but when you do go in there, if you go to purchase, it is per technician. So if you want to do multiple technicians, you're going to need to choose multiple. It will ask you on a drop-down box if you know already the OE that you wish to pursue. If you do, that's great. If you don't and you just want to select one, then we will sort that out with you in the first coaching call. And we don't really necessarily need to know which OE you want to focus on until it's testing time. Because when you tell, let's say Jason, when you tell Jason it's that rocker on the 2020 Nissan Sentra, we're going to go do all the research and be ready for you to give us your presentation.
Yep.
So think about, I got to write my thesis paper, turn it in to the professor, and then the professor is going to watch me perform the job there, is exactly what this is. And so, be ready, because Jason's going to be ready, or Larry's going to be ready, or
there's some homework required, some pre-assignment on here. And again, we had that same issue where, and again, show it to Blaze and his team. Like when I turned that camera on, when they joined, they were ready to go. Kyle was ready to go. Some other ones,
not so much.
Well, what am I doing? So
here's the thing. Some of them, though, I don't think weren't necessarily ready because they just didn't prepare. It was, but that they didn't know how to prepare.
Right.
So we identified there's your gap right there.
Yep.
And very short. Now, when I do the follow-ups, because I followed up on you, and I know you've heard about some of it, right? So I would go behind you and follow up with the owners and go, I want to know what you think. I want to know what your techs think. I didn't get a single negative feedback. And I got a lot of techs that would jump on the phone with me and go, God, Kristen, I really love the one-on-one coaching.
Yeah.
Because I noticed rewatching your replays, a lot of other questions came up. So while we were there with one goal, the techs were asking other questions and you were able to fill that in. But so the techs loved the one-on-one coaching aspect of it. The owners loved finding out that they had gaps. So I did have some owners that got on the phone with me and going, Kristen, I volunteered for this because I thought I was awesome.
Yep.
And I thought I was going to show you, and because who wants to get on the phone with Collision Hub and show their underbelly, so to speak, right? So he goes, I thought we had it, and then we didn't. And so now I'm thinking, oh my God, other cars that had gone out the back of the shop, maybe I didn't know what I thought I knew.
Yep.
So I'm excited.
I'm excited too. Still got a lot of work to do. We got to go build a lot of those OEM programs here, get them out. But that's going to be, when I get back later this week and next week, that's going to be job number one. But keep me on my toes, right? But I'm excited about it. I said I was really looking forward to coming down here. I was kind of hoping we could have announced it last week because I was so excited about it, but it didn't really fit into our workflow process. But collisionhub.com, click on the store and sign up for the training. And we're looking for feedback. And again, we're working with some beta testing with some OEMs right now for their network as kind of a maybe either a replacement for their current welding requirements or as a capstone. So again, go through the basics, understand how to do some welding, and then let's cap it off with that OE specific.
If you want to be a true you want to be a true badass in this industry, to be able to say Collision Hub is signed off on your welding. To make Larry have to sign off on your welding.
So are we getting a new hashtag? Chub Weld? Hashtag Chub Weld?
We shall see. All
right. Well, that's it. What we got?
What's next?
We're back at noon, right, guys? BTAG? Oh, you're not the BTAG. Those are the PDR guys. Look, we're the BTAG. We're back at noon with the BTAG Innovation Group. And then at 3 o'clock, right? 3 o'clock.
Paintless dent repair.
We're going to be back with a whole bunch of extras on paintless dent repair.
My old insurance catastrophe manager hat's going on backwards, and I'm digging into the PDR guys. They're going to regret showing up.
Can we not have her in the class?
Oh, I'm going to be there.
Oh,
I'm there.
We do have also another roundtable today at noon with 8S Things, so Nick will be back on that. We'll post the link to that on the Collision Hub social media channels. And again, don't forget, make your Collision Repair Education Foundation donation. We're up to $1,300.
Bam.
A few things come over the weekend, so excited about that.
Get that Chubb World
your
Fair shirt.
authentic, your Chubb World Fair Collision Repair Education Foundation shirt, and I think I'm going to model that this afternoon because I like it. It's not going to be the actual one, but just a pre-production.
A simile.
A simile, yeah.
A simile.
So
I like
we'll see you